Mechanics and properties of matter, A Factor Academy. We'll be solving second question on mechanics. So out of the numerous questions that we're going to be solving on mechanics and properties of matter in this series for students that are interested in physics in their examination, be it the West Africa Senior Certificate Examination, the NECO, SSC, JUPEB, or any other exams where physics is of interest. So now, going to the second question. An object has a mass of 10 kg. It is placed on a plane inclined at an angle of 60 degrees to the horizontal. Calculate the horizontal force, which will just cause the object to move up the plane if the coefficient of friction is 0.4. Now you have a few seconds to look at the question over and over again. Know the parameters, the mass of the object, okay, the angle of inclination, okay, and some other points like which this statement here, okay, like this statement, which will just cause the object to move up the plane. So we are looking for the what? We are calculating the horizontal force that will just cause the object to move up the plane if the coefficient of friction is 0.4. So let's go. Now this is the, here is what? The floor, okay, this is the ground, and here is the plane. So now it is inclined at an angle of 60 degrees to the horizontal, okay. So we have this. Now this is the object, 10 kg, and it is placed on this plane, okay. So the coefficient of friction is mu, which is what? 0.4, as indicated in the question. So there is a downward force that acts on the object, which is actually the weight of the object, okay. It's acts downward. So from the calculation we did in solution 1, you know that weight is equal to what? Mass times acceleration due to gravity. So if the acceleration to gravity is 10 meters per second squared, then the weight is going to be equal to 100 Newton. Okay, so because the weight is acting this way and this plane is inclined at an angle of 60 degrees, because of the inclination of the plane, what happens? We are going to be having a solution of, you have to resolve this weight. Of course, this object will definitely, okay, will definitely flow down, that is, slip down this inclined plane because of what? Because of the weight of the object. So the weight will definitely make this object to what? To slide down the plane. And that means, of course, you have two components, the vertical component, okay, and here inclined at an angle of 60 degrees, and what? Horizontal component, which is going to be parallel to the plane. Now this angle 60 degrees is going to be what? Equivalent to this angle 60 degrees because of the rotation of the what? Of the plane. So that means if this is 60, this will also be 60. So if this plane is rotated by this whatever angle, then that means the vertical will also be what? Rotated by the same angle. So that means the angle between the weight and the vertical inclination, the vertical component of the weight, W sub y, will be what? The same as the angle of inclination. So now the next thing is what? Look at the normal. So the normal is what? The normal of the plane, normal reaction of the plane on the object n is what we have n. So you can see that it's directly opposite the what? The vertical component of the weight of the object. Now let's look at it. Now we are told that what? An horizontal force P is now applied to the object to move it up the plane. So if that is the case, there will be a frictional force that will act to oppose the motion of the plane if it's to move up the object, rather, if it's to move up the plane. So, and this force too, you can see that it has an inclination, okay? Because if this is the plane, of course, there will be an angle between the force, horizontal force P, and the plane, okay? So let's see. So we have, this is going to be what? The horizontal component of the horizontal force P, okay. So this is the P sub x, okay, which will have an angle, okay, which will have an angle the same as this angle here. Why? Because if you look at this, if you look at this, okay, this is the horizontal component and this is the plane. Yeah, this angle and this angle are they are what? They are alternate angle. Let me use my pen to indicate this. Now these are alternate angle. This angle is also going to be the same thing as this, maybe 60 degree. Okay, maybe 60 degree. Now this is 60 as well. Now, and these are also alternate. So this means that this should be 60. Now, how do we get the value of p sub x and p sub y? Now, look at this line. This line here is parallel to this. Okay. So what does that mean? That means you're going to be having a triangle. So here we have p. This is p. This is p, and here is going to be what? The same thing as what? P sub what? P sub y. So here is p sub y. Okay. And here is what? P sub x. So we have a triangle there. We have a triangle. So we have a triangle. We have a triangle. So we have this is 60. This is 60 degree. Okay, this is 60 degree. So here is what? Here is 90. And here is going to be automatically, that's going to be what? 30 degree. 30 degree. So this is 30. So automatically this is what? P sub x. This P sub x. And here is what? P sub y. And here is what? Here is p. Okay, here is p. So automatically looking at it now, you can see you can get the value of p sub x, p sub y, and with respect to p, which is what? Horizontal components. From here, sine 60 is going to be equal to what? Sine 60, okay, sine 60 degree, which is the angle that this vertical horizontal component make with the what? Horizontal component of p make the what? The horizontal p. So sine 60 degree, okay, is going to be equal to what? It's going to be opposite p sub y, okay, over what? Over the hypotenuse, which is what? The side that is directly opposite the largest, okay, angle, which is what? P over p, okay, over p. So p sub y automatically becomes p sub y becomes p sine sine 60. Sine 60. Okay, so this is going to be p sub y. And from here, you can get p sub x. So if you get cos 60 as well, cos 60 degree, okay. If you look at cos 60 equals to, from here, that will be the side adjacent to this angle, okay, adjacent to this angle, which is what? P x apart from the hypotenuse, p sub x over what? The hypotenuse, which is what? P. So automatically, that means p sub x equals to what? Equals to p cos 60 degree. Cos 60 degree. See? So now we have seen what p sub x is and what our p sub y is from here. So we have seen what p sub x is and what p sub y is. So from here now, since we have gotten what p sub x is and what p sub y is, of course, normally we know that this is going to be the same thing as w sub x. So that means w sub y, from what we know before, w sub y is going to be equal to what? W sub y is going to be equal to, w sub y will be equal to, because this is vertical component, okay? So that will be equal to w cos 60 degree. And W sub X will be equals to what? Will be equals to W sine 60. Actually, this is actually gotten from the triangle. If you have to rotate this triangle, so you're going to be having something like this. Okay, where this is going to be 60. It's going to be 60 degree. This is going to be 60 degree, and here is going to be what? W sub Y, and here is going to be W sub X, and here is going to be W. So if you use your SO calculator, your SO, like we have done in the previous, in calculating for P, your SO car, okay, and so R, then you can get all these things that we have done now. That is, so sine of an angle is equals to the side opposite over the what? The hypotenuse. Then cos of an angle is equals to the side adjacent over what? The hypotenuse. And tan of an angle is equals to what? The side ratio of the side opposite that angle to the adjacent of the side to that angle. So this is what we have done that will actually help us to solve problems as far as what we are doing here is concerned. So now that we have seen this, what's the next thing to do? The next thing to do is to solve this problem. Now we have to get the horizontal component of the force, not just the horizontal component, the horizontal force P that will keep this body of the plane. So let's clear this. Let's clear this highlight. Let's clear this highlight. Okay, before we go into solution, let's clear this highlight. So let's clear this highlight. Let's clear this highlight. Let's clear this highlight. Let's clear this highlight. Let's clear all of these highlights. I don't think I'm going to do need of it again. I believe this is copied down somewhere for everybody to use. So let's clear this so that we can solve everything now. Although I will still make reference to them in my notes. So let's clear all of this to make our work look neater. So very good. Now we have all this. So let's go back to our pointer. So very good. Now recall this that from the relationship between frictional force and normal reaction, that is the factors affecting solid friction. Okay, we know that frictional force F sub F is dependent on the normal reaction. Okay, so such that F sub F will now be equals to mu n, that's mu times n, where n is normal reaction. And since this body is what is kept stable on this plane, okay, that means summation F sub x equals to 0, and algebraic sum of all vertical components, summation F sub y also equals to 0. So what else? So for the resultant vertical force, that means resultant vertical force is 0. What does that mean? That means all the vertical forces here, this is vertical to the plane, this is vertical, another vertical force is this. So we have this one, this, and this. They are all vertical components. So looking at it, the normal reaction is moving up, weight is moving down, and P sub y is moving down. So that means net force in one direction minus net force in the other direction will be equals to what? Equals to 0. So look at it, n is moving up, so n minus all the ones moving down, P sub y plus what? W sub y. Okay, that gives us 0. And you know that what that means that what, when you take this to the other side, make n the subject, n equals to P sub y plus W sub y. Okay, now where P sub y, okay, from what we have done earlier, P sub y is P sine theta and P sub x is P cos theta. So we have established that earlier. And W sub y is what? W cos theta. W sub x is what? W sine theta. So what do we do? Therefore, what does that mean? That means if you put all this into this, then that means n will be equals to P sub y, which is what? P sin theta plus W sub y, which is W cos theta. Make that equation 1. Now, let's look at the resultant horizontal forces. Resultant horizontal forces, of course, is going to be equal to 0, which is what we mean by this. This is horizontal force, this is vertical. We have done for vertical, let's look at horizontal. Now, for the horizontal forces, where are the horizontal forces first? Let's identify them. P sub x, S sub f, W sub x. You see that P sub x is moving up, S sub f is moving down, W sub x is moving down. So that means we're going to be having P sub x equals to or minus the sum of this. So that means P sub x is equals to what? S sub x plus W sub x. Very good. So that means P sub x is what? P cos theta equals to what? F sub f from the relationship between frictional force and normal reaction. That means P sub x, which is P cos theta, will equals to mu times n, or mu n plus W sub x, which is what? W sin theta. That's equation 2. Now, what do we do? Let's solve n in 1, okay, n in this one, into the value of n in 2. So what do we have? We have P cos theta equals to what? Mu n, where n is what? P cos P sin theta plus W cos theta, everything plus W sin theta. Very good. So now what's the next thing? Let's impute the parameters. So imputing the parameters, the angle theta is the same on to, which is 60 degrees. So P cos theta equals to what? 0.4, which is what? The coefficient of friction. Okay, this case coefficient of static friction. Okay, times what? P sin theta, which is 60 degrees plus 100 cos 60 degrees, close the bracket, plus what? 100 sin 60 degrees. So let's go. What do we have? Cos 60 degrees is what? 0.5. That's half. So half P, or 0.5 P, equals to 0.4 times, okay, expand this, sin 60 is what? 0.866 P plus cos 60 is half. So half of 100 is 50. Okay, so plus what? 100 times sin 60. Sin 60 is 0.866. So times 100, that will be 6.6. So solving this, you need to expand this bracket too. So let's expand. So 0.5 P equals to what? 0.4 times 0.866 P give us 0.3464 P plus what? 0.4 times 50, that's 20, plus 86.6. So what would that give us? 0.5 P, okay, collecting like times now. Take this, that's what we have here, 0.3464 P. Take it to this side, okay, that's the same time in P to this side. So we have 0.5 P minus 0.3464 P, which is going to be equal to 20 plus 86.6, which is going to be 106.6. Very good. So 0.5 P minus 0.3464 P give us 0.1536 P equals to 106.6. So P equals to 106.6 divided by 0.1536, and therefore the horizontal force P equals to 694.01 Newton, which gives the what? The horizontal force P that is necessary to push this object up the plane. This question is quite interesting. So it's one of the questions that we need to have a conceptual understanding of physics to be able to solve. The most important thing is to be able to what? Interpret this question like I've done here. The interpretation will help us to be able to solve this problem. If you are unable to interpret it appropriately, then you might find it difficult to solve. I believe with this solution, any other questions of this nature will be easier to solve. More to come in subsequent lessons. If you have any comments, please kindly feel free to put your comments in the comment section. Don't forget to subscribe, like, and share my video. I'll be glad to be here once again. Thank you.